No.
You have not seen this kind of question earlier, right? But irrational number is in your syllabus. This proving statement is in your syllabus. Okay, so let me discuss. So before understanding this proof, we must have to discuss fundamental theorem of mathematics. There is a fundamental theorem of mathematics. So let us discuss that thing first. So let me write that is fundamental theorem of mathematics. See, suppose there is a number a square, right? Suppose there is a number a square, and if you are dividing this a square by any prime number, please see very carefully. If this there is a number a square, and if you are dividing it by any prime number, suppose the prime number is
Two.
p1. Suppose let me write the tell me the statement. So if you are dividing this a square by any prime number p1 and it is getting completely divisible, so this is the if condition. Please see, this is your if condition. If a square is divisible by prime number p1, you have to return this explanation again back to me. So listen carefully. If a square is divisible by a prime number p1, then a will also be divisible by the prime number, the same prime number p1. Let me give you some example also. Have you understood this statement? What's the statement is? If a number a square is divisible by any prime number, say p1, then a will also be divisible by that prime number p1. So suppose there is a prime number 2, we can divide 4 square, that is 16. 16 is divisible by 2. So 4 will also be divisible by 2, correct?
Yeah.
See another example. For example, we have number 11, right? And 121 is divisible by 11, which is the 11 square basically. So 11 can also divide 11. You can take any other example. For example, mm, take any other 3 and 9, which is the 3 square. So if this prime number 3 can divide 9, so this prime number 3 can divide this 9 is basically square of 3. So it can divide 3 also. This is a very fundamental thing. If you think logically, then you will say this is the obvious thing. But this thing must be a prime number. You are dividing it by a prime number. If you are dividing any number which is in a square form by any prime number, and if it completely divisible, then that prime number can also divide the base of that perfect square number. Can you return it to me? This statement. Please re-explain back to me. What is this?
So you said in this like fundamental concept in math, if a number a squared um, for any value of a is divided by any prime number and the remainder you get as zero, that same condition will apply if you divide that prime number by a. You will also get a remainder of zero.
Correct. Understood it? Verified it? No doubt, no confusion, no controversy?
No.
Okay. If you have understood this one, then only you can understand this proof and you can write it in your examination successfully. Otherwise, you will stuck at many places. Okay. So see, we have to prove by contradiction. So first of all, I will assume that let root 3 is rational. I have assumed that root 3 is a rational number. After that, I will create some controversy. I will create some contradiction. I will create some problem in my statement, and then I will prove that okay, this is it means this assumption was wrong. I have assumed right now that okay, for the time being, we can assume that root 3 is a rational number, right? So if root 3 is a rational number, it means we can write this root 3 as p upon q, where q should not be equals to 0, and p and q belongs to your co-prime number. Is it okay? Do you know what's the co-prime number is?
No.
Search it on the Google and explain it back to me. What is co-prime number?
There are two or more integers that have exactly one common factor,
Can you give me some example?
like 2 and 3.
2 and 3. So see, if we investigate this word. Co means together. We have discussed many times. Co means together, and prime means prime number. It means those pairs of two numbers whose common factor is 1, and that is 1. The common number of common factor will be 1, and that common factor will also be 1. Or we can say in another way that the HCF of those two numbers should be equals to 1, must be equals to 1. Are you getting what's the meaning of co-prime? See, for the co-prime number, it doesn't mean that both the numbers should be prime, or at least one of the numbers should be prime. There is no such condition. See, in this way, both the numbers are prime, still they are co-prime. We can have 4 and 9 also. See, none of them are co-prime. None of them are prime. See, 4 and 9, none of them is prime. But still, the pair will be called as co-prime because their HCF will be 1, because their common factor will be 1. Are you getting my point? And we can have obviously 4 comma 11. See, in this one we have one prime and one non-prime. In the first one, in 2 and 3 both are prime. 4 9 none of them are prime. 4 and 11 one is prime, one is non-prime. So there is no any condition that at least one of number should be prime or non-prime, like this. Any combination is
Okay.
okay. So there is one and only one condition, that the common factor should be 1, and that is 1 only. And in another way we can say the HCF will be 1. Any doubt?
No.
So we have assumed that P and Q are co-prime number. Q should not be equals to 0. This is the standard form of rational number. In the simplest form, this is a standard form. They should be written in this simplest way. Okay. So by doing the cross multiplication, we can write that P is equals to root 3 times Q. Can we write this? If you do the cross
Yeah.
multiplication, squaring both sides. If we do the squaring both sides, what I will get? Squaring both sides, we will get P
P squared
squared
is equal to 3Q
3Q
squared.
squared. What does it mean? We have discussed in the last class the meaning of this statement. It means P square is divisible by 3. See, can you see that? See, 3 is a factor of P square. The statement, this can be explained in this way, that the 3 is, there are many ways to understand this. The first, we can understand that 3 is a factor of P square. Am I right? 3 is a factor
But
of
that
P square.
but you said if it's rational, they have to have two co-primes, which are have a highest common factor of 1.
Between what? Common factor of what?
You said that when the number is rational, right?
Mm-hmm.
P
Mm-hmm.
comma Q is equal to all co-prime numbers which have
Yeah.
highest common factor of 1. But you
Yeah.
just said 3 is a factor of P squared.
P square. I'm not talking about P. And I've told you that we are commenting on P square, not P and Q. I have already told you in the
Okay,
co-prime number.
so 3 would also be a factor of P. If it's a factor of
Obviously.
P squared, why would it be a
Obviously.
factor?
Yeah, that's the same thing I have explained just before. So 3 is a factor of P square. 3 is a prime number. So as per this fundamental theorem, we can say that 3 is a factor of P as well. There is no contradiction till now. I have told you that in the co-prime number, 9 can be possible. I'm not talking about P and Q right now. I am talking only about the P. And P can be prime, P can be non-prime. What's the matter? Tell me any doubt if you have. Are you getting my point? We have
Yeah.
written that P and Q in a pair should be co-prime. I have explained in the co-prime number doesn't mean that both the numbers should be prime. See, I have written this example. 9 can be your prime, one of the number of the co-prime set. So what's the problem? No
Okay, I
problem.
get it.
This statement can explain in the pictorial way also, that it means P square is divisible by 3. We have discussed this in the last class also. This P square is written as 3 into Q square plus 0. It means the remainder is 0. Are you getting my point? So as per the fundamental theorem, we can understand it as 3 can divide P also. Are you getting these mathematical ways, these pictorial ways, both the ways I'm taking this explanation. Okay? Any doubt?
Okay.
Now, reverse. If P is a factor of, if 3 is a factor of P, now see, if 3 is a factor of P, what I'm saying, if 3 is a factor of P, this is a statement written in English language, that 3 is a factor of P. Can you tell me how I can write in mathematical way? 3 is a factor of p. It's a English language.
You
How?
already wrote it in a mathematical way. When you divide 3 by p,
This is
you get
not
a
a
remainder.
mathematical language. This is a pictorial language. Am I right?
Oh, okay, so what would you? Okay, so fine. P over 3 is um some number plus 0.
Yeah. So correct. So you should write p is equals to, we can say, lambda times 3, where lambda is an integer, right? You should write that lambda belongs to your integer. Is it okay? Are you getting this point? So this is
Okay.
the mathematical way to say the same thing, that 3 is the factor of p. Is it okay? Are you getting this?
Yeah.
Now, return, we can substitute this p condition again back to this original condition. I'm again back substituting this p into this expression. What I will get? So p square, it means 3 lambda whole square is equals to 3q square. Am I right? See here? Tell me, any doubt?
Okay, so lambda's q.
Don't go one step
No,
ahead. Just be, in level with me. Otherwise, there will be a mismatching. I'm saying this again and
oh,
again.
okay, so 9 lambda squared is 3q squared.
9 lambda square is equals to 3q square. It means 3 lambda square is equals to q square. Or in another way, we can write q square is equals to 3 lambda square. What does it mean? Can we say that 3 is a factor of what? 3 is a factor of q
Lambda.
square. Mm-mm. 3 is a factor of q square. Am I right? See? It means 3 will be a factor of q also. It
Okay.
means now there is a contradiction. Now there is a contradiction. We have assumed that P and Q in pair are co-prime. It means they should have
But their
maximum
highest
one
common
common
factor here is both 3.
1. Whereas right now we have proved that 3 is a factor of P also. 3 is a factor of Q also. It means P and Q are not belonging to co-prime, which is a contradiction here. Are you getting this proof?
Okay. Okay, I'm getting it. It's a bit long. How am I supposed to remember these rules that if I have like an irrational number, like they have to be
Which
co-prime?
which difficult rule we have used? Tell me.
We haven't used a difficult rule. It's just that there's just a bunch of ways which you can write stuff that I don't know about.
That's why this is the conceptual thing I'm saying. Why I'm saying in detail. So this is a question. This is asked many times in all levels of the examination. See, that's why I have make it
It's
very
just
crystal clear that
yeah.
you must aware of these things separately. Then I have written so many things. That's
Okay.
the concept. Okay. Any other? No.
No, not on
Based
this
on this,
question.
based on this, I will suggest try one more question. Right? Prove that root 2 is an irrational number. Try this. Then only you can say with
Okay,
guarantee that you
so
can solve it. Follow the same steps.